There is a kind of silence that only space can hold. Not peaceful, not hostile, just indifferent. The universe does not perform for us. It does not warn us. It does not pause to be understood. It simply continues. And somewhere inside that continuing, on a small rocky world, a thin atmosphere clings like breath on glass. Light look at the earth. A blue point wrapped in a layer of air, so thin that if the planet were the size of a basketball, our entire sky would be thinner than a coat of paint. All of our history happens inside that paint. Every city light, every war, every love story, every promise. And above it, a vacuum that doesn't hate us. It just doesn't notice. Now zoom out. Earth is a peppercorn. The sun is a beach ball. 150 million kilometers apart. Close in cosmic terms. Dangerously close for a civilization that runs on wires. The sun releases energy on a scale that breaks intuition. Every second, about 400 trillion joules pour out into space. Try to hold that number in your mind. Gather every nuclear weapon ever built. Stack their combined explosion energy into one brutal pile. Compared to what the sun emits in a single second, that pile becomes a spark next to an ocean of fire. This isn't poetry, it's arithmetic. And the difference between arithmetic and catastrophe is often just timing, because the sun is not a calm object. It is not stable the way a stone is stable. It is plasma, a living sea of charged particles, constantly boiling, constantly moving, constantly threading itself through magnetic fields we cannot see. And sometimes those invisible fields store enough energy to shake a planet's technology without ever touching the planet itself. Tonight's story is not about a monster. It's about a reminder, written in physics. A Carrington-class solar superstorm, not a myth, not a fantasy, but an event that has happened before. Only now, we have built a civilization that depends on delicate things: timing, synchronization, satellites, grids, networks. A global nervous system that assumes the sun will behave like a polite background light. But the universe does not do polite, does not do scale. And scale is the closest thing to cosmic terror that mathematics can describe. The sun has blemishes, dark sunspots that look like stains on its surface, but they are not dirt. They are magnetic knots, regions where the sun's magnetic field pushes upward and tightens, where plasma is trapped and twisted, like a rope under strain. The sun rotates, but not like a solid ball. Its equator turns faster than its poles, so the magnetic field lines stretch, shear, and tangle, patiently storing energy like a drawn bow that never gets tired. And then a moment comes when the geometry can't hold. A process occurs with a name that sounds gentle for something so violent: magnetic reconnection. Field lines break and rejoin, snapping into a lower energy shape, and the stored energy releases. Follow. First, a solar flare, a burst of radiation, X-rays, and extreme ultraviolet light that races outward. At the speed of light, no particles have to arrive for the flare to matter. Light itself is enough to disturb our atmosphere. Second, a coronal mass ejection, a CME. Billions of tons of charged plasma thrown into space as a magnetized cloud. Not aimed, not targeted, just launched by the sun's own dynamics, into the indifferent dark. If that cloud intersects Earth's orbit, it meets our planet's magnetic field, a protective bubble that deflects much of the solar wind. But protection is not perfection. When a CME arrives, Earth's magnetic field compresses, then rebounds, then oscillates, like a bell struck with a hammer, too large to fit into the human imagination. And the ringing of that bell does something subtle, something cruelly modern. It induces currents in our long conductors, power lines that cross continents, pipelines that run for hundreds of kilometers, infrastructure designed for stability, suddenly forced to participate in a storm that began on the surface of a star. A solar superstorm is not fire in the streets. It is not a meteor impact. It is not a cinematic explosion. It is an invisible mismatch between space weather and human engineering. A reminder that the grid is a machine built inside a magnetic environment, and the environment can change, sometimes fast enough to hurt. Imagine it happens now, this minute. A Carrington-class event unfolds on the sun. Archie first. Nothing changes on Earth. No shaking ground, no falling sky. Just normal life under an ordinary morning or an ordinary night. But the clock has started. 8 minutes and 20 seconds later, the radiation arrives. The ionosphere, that electrically active layer of our upper atmosphere, ionizes rapidly. High-frequency radio can fade or fail across the sunlit side of the planet. Aviation routes that rely on certain bands. Here static, then silence. Navigation signals begin to distort, not everywhere, not all at once, but enough to make precision uneasy. Most people still notice nothing because our world hides its damage behind screens and systems. Minutes pass, then come the fast particles. Energetic protons stream toward Earth, guided by magnetic field lines. Into the polar regions, radiation levels rise. Satellites take hits that are not dramatic, not visible, but technical. A single event upset, a flipped bit, an error that becomes a reset that becomes a failure that becomes a service outage. A civilization built on near-perfect timing begins to lose its rhythm. But the worst is still traveling. Far behind the light, behind the first particles, the CME moves like a heavy wave of magnetic cloud, crossing 150 million kilometers through emptiness. When it arrives, Earth's magnetic field compresses, then it whips back. And as the magnetic field changes, it induces electric currents in the longest wires on the planet. Power grids are not only delivery systems, they are continental-scale circuits. They are, in effect, antennas. Now, the second-by-second impact at second 1. Grid sensors register abnormal currents. In long transmission lines, second 5, protective relays begin to trip. In stressed corridors, second 10, voltage fluctuates at frequency wobbles. Second 20, operators shed load. 2, prevent a cascade. Second 30, a transformer in the wrong place starts to overheat. Second 40, another station trips to protect itself, and the load shifts elsewhere. And the elsewhere was already near its limit. Second 50, a cascade becomes momentum. Second 60, Blackout becomes geography. City blocks dim, then districts. Then entire regions. Traffic lights go dark. Subways slow and stop. Elevators freeze between floors. Hospitals switch to generators that were never meant to power a city. Only two by time. Cell towers rely on batteries. Batteries drain. Data centers rely on fuel. Fuel runs out or cannot be delivered. And the internet, that invisible world we treat like air, reveals what it truly is. Buildings, cables, cooling systems, precise clocks, and electricity. As those supports falter, connectivity fragments, services phrases, financial systems struggle because time synchronization degrades, and modern finance is built on time as much as on trust. Payment terminals go down. ATMs stop, not because money vanishes, but because verification vanishes. Supply chains that are optimized for speed discover what they sacrificed for efficiency. Slack within hours. Stores cannot restock. Fuel distribution slows. Refrigeration fails. Water pressure drops in places. And then, as if to mock the human sense of priority, the sky becomes magnificent. Auroras spread far from the poles, green and violet curtains, rippling over cities that can no longer light themselves. People step outside to film it and find their phones dying, their networks silent, their usual channels gone. The storm is not loud. It is not a roar. It is a subtraction. Connectivity removed. Certainty removed. Convenience removed. Until what remains is the older human world, neighbors, voice, firelight, and the slow return to direct reality. In the days after, satellites in low Earth orbit face increased drag as the upper atmosphere heats and expands. Some burn fuel to maintain altitude. Some cannot. Weather forecasting loses clarity. Navigation loses reliability. And the hardest repairs are not software fixes. They are hardware, massive transformers, specialized machines, built to order, shipped with difficulty, replaced with time. In mild scenarios, restoration is measured in days. In severe scenarios, it is measured in weeks, sometimes longer. And through it all, the sun continues to shine with perfect indifference, as if nothing happened, because for the sun, nothing. This is not a prophecy. It is a reminder that our technology exists inside a larger environment that does not consult us. The universe is not cruel. Cruelty requires intent. The cosmos has none. It follows rules, and sometimes those rules intersect with our dependence on fragile systems. But this story is not here to leave you afraid, because vulnerability is not fate. Once it is understood, we can prepare. We can harden power grids, add protection against induced currents, design transformers with resilience in mind. We can improve space weather forecasting, move satellites into safer configurations, build redundancy into navigation and communication. We can create systems that fail gracefully, instead of collapsing like dominoes. And there is something else worth remembering. Look at what normal requires. Lights that answer a switch. Water that rises into towers. Voices that cross oceans. As if distance were nothing, This is not guaranteed. It is an arrangement delicate, brilliant, temporary, held together by engineering, maintenance, and a narrow window of stability under a star that does not know our names. So if one day the sky above a silent grid, let it not only be a warning, let it be a perspective, because in the vast indifference of space, life is an improbability that happened anyway. Matter learning to think, stardust forming eyes, a planet briefly becoming aware of the star it circles, and that awareness the ability to plan, to adapt, to care, to rebuild, is not small, not in the only scale where meaning exists. The human one. The cosmos does not need meaning, but we do. And even under an indifferent sky, we are capable of making it.